Shall we? All right. Thank you, everybody, for coming to the MOPS working group session. If you didn't think you would come to the MOPS working group session, it's a good time to find somewhere else to be. So I'm Leslie Daigle. I'm one of the co-chairs, and this is Kyle Rose, other co-chair of the working group. And Glenn Dean, our technical advisor, is in the audience. Next slide. Who's driving? Sorry. Yep. So this is the note well, which you should have already noted well, because when you registered, you agreed to all of these terms. This is important for the management of intellectual property disclosures, so on and so forth. And all of the appropriate IETF policies, et cetera. And then there's a note really well. Oh, so we've already gone to IETF meeting tips. Since this is Monday, you might want to make sure that you are taking note of the tips, including make sure that you sign in to the MeetEcho client. If you're in this room, please make sure you do sign in to the on-site tool. We will be using the MeetEcho queue for all Q&A, whether you're here or remote. So it's imperative that you sign in. Also, if you sign in, you let the IETF Secretariat know how many people showed up, and we can size meetings accordingly. Okay, next slide, please. Other useful resources. I'm sure you have already found the agenda for the overall meeting. There's more information about the MeetEcho tool if you need to find it. And if you are having issues, please make sure to use the meeting issues page. Next slide, please. Great. So we have a packed agenda. We have a 1-hour slot. So again, thank you everyone for being here. Thank you to Chris Lemons for being our note taker today. And are there any bashes to the agenda? Not hearing any bashes. I think we're up with you, Sanjay, please.
Okay, my name is Sanjay Mishra. Oh, slide. Thank you. My name is Sanjay Mishra from Verizon, and I'm presenting the network overlay draft, which is co-authored by my colleague, Glenn Dean from Comcast, who's in the audience, as Leslie said. So let me get started. So some of those that are new to this working group or attending for the first time, just to recap what this draft is about. It's about network overlays, and the network overlays basically is how we're defining it as a concept that any function that first stays on top of the native network, and it may have influence over certain policies such as routing, DNS addressing, and other things that actually overrides the native network. So an example of that would be Mask, for example, Apple's iCloud Private Relay, which are privacy enhancing tool, and they ride on top of the native network. The intent of the overlays is really to increase privacy and also have operational side effects, which is what for the video streaming, and which is what this draft is all about. So context and purpose, as I said, the draft is focused on exploring areas where we see impact to video streaming, and it focuses primarily on the operational challenges and some of the architectural implications from it, but we don't go into the protocol design or any of that. The current version is 0.3. Let me go through okay, I'll come back to the changes to it. This is the data tracker timelines of the version 3 and how we got here. So we submitted last July 2024 in Vancouver in IETF 120 draft 00 of the individual draft, and then submitted a revised version 02 before the Dublin session. And at the Dublin session, the draft was adopted, and which we submitted working group draft in February, and followed by the 3 drafts just before each of the sessions this year at the IETF, including the version 3, which we now have submitted just before the meeting. So what are the changes in the draft from version 2 to 3? So there's a lot of editorial cleanup and tightening across the sections. There were redundancies that we found that have been removed in terminology, and also streamlined the introduction section from before. Have expanded examples that we have already included with some more details on areas such as the routing, DNS, and IP address and the protocol, etc. Also added clarity on the operational scope, and just explained that the scope is just not HTTP video, but other streaming system as a whole. And also improved some of the linkages between the overlay privacy goals and the streaming impacts. And then there are some other fixes throughout the document in the reference style that we used. So those are the changes. And so going into the meat of the document, so this is just some of the examples that I've taken out from the draft and laid it out so that the audience have a sort of a quick view of where we are headed and what are the areas that we have discovered in the document and have documented. So essentially, if you look at the 3 columns here, the left is the categories of areas that we have found, challenges, and the functions that they impacted, and typically how they have manifested as issues or things that sort of don't align with the smooth streaming delivery. So for example, the categories that we have discussed, and this is not an exhaustive list, the document has all the use cases that we have covered that we could identify. So the categories is IP address, policies that change IP addresses, and the impact that they would have on determining the session authentication, etc. And then a user might fail that authentication. I'll go through the details in a couple of slides, but sort of just giving a view of these are the areas that one way or the other get impacted. Geolocation changes, for example, and that might interfere with whether or not the user is able to view the content that they think they should be able to view. Also, the policies that change routing may have impact on the cache selection for content streaming. That might lead into higher latency and obviously suboptimal cache. Changes that are made to the DNS policies would also have cache selection, and this may also lead into higher latency or even increase the time for delivery. Also, other areas are the CDN interconnection troubleshooting that would cause issues between the CDN operators. And also operationally challenges to identify and troubleshoot issues as they relate to changes made in the policy, such as the routing or DNS, etc. So I'm just going to try to pick up a couple of examples to go through the examples. But if you have not read through the document, it'll be great if you can review it and make comments on the list. So just to pick an example here, this is a policy that actually overrides an IP address that might be assigned by the local ISP. But if the overlaying network changes that, that we have seen in examples in the network that we've seen that a client is not authenticated or CDN is not able to associate correctly to the ASN that the user is coming from. And that has impacts that basically would end up denying the service to the user. Geolocation sort of has the same thing with the geolocation changing. You would have issues which would impact whether or not you can view the content that you are authorized if you're home versus if you're not home, then a certain content is not available. But in this case, even if you're home, but the changes to what your geolocation is would impact the viewing capabilities otherwise. This is the similar example of changes to the routing policy, and that would result into rerouting flows through a distant node that would affect your basically CDN cache selection and degrade your quality of experience. Impact areas, CDN cache selection, your bit rate, path optimization, all of those end up manifesting into your experience. And I probably have time, so I can maybe even continue.
I think we should pause and ask if there are any questions. One of the points here is that this document is, the authors feel like they have not been receiving new suggested impacted changes. They've added material around the specific issues that have been raised. So it's probably ready to go to working group last call. So if you have any questions or issues about the things that Sanjay has raised so far, please get in the queue and head to the mic, which is an opportunity to say for those of you who have joined in the last few minutes, please do go ahead and sign into the on-site MeetEcho tool because we're using that for queue management.
Thanks, Leslie. So yeah, that you have fast tracked to the question, and really I also wanted to get to the point that we have basically exhausted in terms of any other or new use cases that we can identify. So I think the meat of the document is pretty much complete in the sense that there are no new use cases. So I think we basically have nothing more to do other than reread the draft and make editorial changes. But importantly, we want to get feedback. A, if you have a use case, or B, if you think that some of what is captured can be improved or has improved, or the problem that we think are there are not there. So those would be the kind of feedback that would be very useful in trying to come to some closure on the draft.
Having the responsibility for MOPS. So good work. I would suggest to the chair that the working group last call is forwarded to other working group, like TSV Art, for instance. Sounds reasonable. Just a suggestion.
From the lack of other questions in the room, I'm going to assume that people here are going to be positive and supportive of this document as it stands when we do go to working group last call. Glenn?
And so, Glendine, I want to make one comment, which was, while we think we're exhaustively completed stuff, a lot of people may find that they actually have this scenario in their own operational environment. And you may think, oh, I don't have that. You probably do. You may not know it. So read the draft if you haven't, and then apply a filter where you basically say, could this happen to me? And if it did happen to me, what comments would I like to make in? Because you probably, if you haven't got it, if you don't think you got it, you actually probably do have it. It's pretty common. You may not know it though.
Okay. I think that's probably good enough for today, Sanjay. I think that the appropriate issues have been raised, and we'll. I don't see any issues with going to working group last call, though I suspect it may take a few iterations from there.
All right. Thank you. Thanks, everybody.
Thank you, Sanjay. Next, we have Lenny Giuliano.
Thanks. So we're going to be having a side meeting on Wednesday, and the topic, I think it overlaps very well with this group. We would love to have folks from this working group involved and joining the conversation and discussion. It's a topic that I think crosses, overlaps with a number of different working groups, MBOND, MOPS, Quick, MOQ. But we think definitely, probably this working group is as relevant as any. So what is the purpose? The world kind of changed a little more than 3 years ago. The world of streaming changed about little more than 3 years ago. But the way in which we deliver that content kind of remains the same. And specifically when it comes to live streaming. Live streaming events with tens of millions of viewers are now relatively common and routine, and it's pushing the limits of what the network can handle. I mentioned 3 years ago, that's when Thursday Night Football was first carried exclusively. It's American football in the US over Amazon Prime. And it represents 25% of all internet traffic on a Thursday night is a single event. This isn't just an American phenomenon. You've seen similar things across the world, nowhere more so than in Asia, where cricket, IPL, and World Cup cricket kind of has really astronomical numbers in terms of how many viewers they've had for those events. And kind of the Tyson-Paul fight was like a really clarifying moment. It set a number of records: 65 million simultaneous viewers, as well as 85,000 complaints and 2 class action lawsuits. The challenge for network planners is that they must plan and design capacity around those peaks, not average. So you can't just dismiss those as one-offs, because first, they're not that unusual anymore, and you have to plan for those one-offs, even if they were. Key thing to note is that live streaming is not the same as on demand. I think the folks in this room have a great appreciation for that. There's things like latency and join rates that are vastly different than what you typically see on typical on-demand streaming. And the key thing is, we're going to look at multicast to address this and what is missing. Multicast solutions have existed in kind of 2 different worlds. There's the network people, the layer 3 people, and TreeDN kind of put that together with SSM and AMT. So from a network perspective, there's a good solution there, thanks to this working group. But at layer 4 and above, there's also been a number of streaming advancements, using UDP for ultra low latency, things like multicast extensions to QUIC. There's been lots of other cool things going on in the space of congestion control, reliability, adaptive bit rate, encryption, all related to multicast. But there's not a lot of awareness between those 2 worlds. So our goal is to bring these 2 worlds together in the same room and discuss what are the challenges of using multicast for the internet for live streaming. We're going to do a gap analysis of what works today and what is missing, and with a primary focus on the layer 4 and above. So things like reliability, ABR, encryption. In terms of agenda, we'll set things up with a discussion of, is multicast a bad idea whose time has come? And then we have a couple speakers that will talk about streaming multicast technologies, as well as multicast for ultra low latency and how it's being used today. And then that's about half the agenda. The other half of the agenda is just open discussion. So we would love for the folks in this room to come join us. Please do. We'd love to see you on Wednesday.
Great. Glenn, quickly.
Quickly, I can't come to this because I'm on non-com this year and we're very busy. I would like to say, in your agenda, I do not see anything about rights management or geo filtering, which is very much connected with this, because you may have different broadcasters having different rights in different territories. And if you multicast, the internet doesn't architect that way, but content delivery does. And so you might want to have to figure out how you would mesh geo things, and also different broadcasters, because they will potentially broadcast the same content, but with different encodings. So you can't just join them all together.
So my naive answer to that, and tell me if this is too naive, is encryption. So encryption requires a certain distribution of that decryption key. And so you can join the traffic wherever you are. And if you're not, if you don't have the rights to it because you're in the wrong location, you shouldn't be given the decryption key. And that's a relationship that you can have directly one-to-one.
And I'll say, Lenny, you're a good engineer and you've got a solution mode already. I'm just simply saying you should include it in your agenda as a topic to
Okay.
talk about. So
Great, great. Okay, thank you.
Great. Thank you, Lenny. And anybody else with questions, you know where to be midday on Wednesday. Thank you. Roger, you're up.
We are going to do a little bit of an AV shuffle here. So let's everybody cross their fingers and hope this works. Okay, let's see. So that's to share. This one, no. And okay. And then apply. See what happens. Okay, I think it works. Hi, let's continue doing that. Okay. Hi, my name is Roger Pantos, and today I'm going to take you on a whirlwind tour of content steering, which is a protocol that is used in HLS and Dash. So first of all, content steering arose because large streaming providers have multiple redundant paths to their content, and the providers wanted a way to control which path their clients chose. So I'm going to explain that in a little more detail. I'm going to start with a quick refresher on HLS, how it works. Then I'm going to talk about how large content providers deliver their content, what their lives were like before content steering, and how that drove our design objectives, how content steering works, some stuff that happened after we released content steering, and then a little bit about the spec itself. So, HTTP live streaming. It's a media transmission protocol. The content provider starts by chopping up their audio or video into short segments, a few seconds each. Those segments go into media playlists, which are just text files of segment URLs and tags. And the client, the player, then downloads the media playlist and then downloads a segment, plays it, downloads a segment, plays it to play through the asset. In live HTTP live streaming, the provider is constantly adding new segments to the end of the playlist, and the player is reloading the playlist to discover the segments. There is a top-level playlist called the multivariant playlist, and that contains a list of media playlists. It has the different playlists at different bit rates of the same content. It can also contain different languages like English and Spanish for different types of speakers. So the client will actually switch between these playlists at different bit rates to match the quality to the network speed. This is what we call adaptive bitrate streaming. And this switching is something that content steering uses. So you serve HLS by putting your playlists and your segments on an HTTP server. Providers at scale use proxy caches to support, as we heard, thousands, millions of concurrent viewers. Once providers become global, though, or they reach a certain size, they tend to use, they want to use to distribute their content over more than one CDN. And they do this because some CDNs are better in some regions than others, and also for various economic factors. Now, resilience is the other primary reason to operate multiple redundant streams. Providers can have primary and backup encoders, primary and backup origins, even geographically diverse data centers. Now, not only do you have a lot of redundant pathways, but the one you'd like your clients to use can also change dynamically. For instance, you might want to move your users to a different, maybe cheaper CDN after prime time. Over time, assets may move from being on demand to kind of cold storage. And more importantly, you want to steer your users around network outages, that are unscheduled network disruptions. Across all of these events, everyone has the same primary goal, which is to deliver uninterrupted service to the user at a high quality of service. So, given that, let's look at what life was like before content steering. While servers could provide redundant playlists, such as East Coast and West Coast, they had no control over which ones their clients chose. They had no way to tell a client to go elsewhere if an outage crippled a particular interconnect. They were limited to the same set of playlists that they provided when the playback started. And on top of that, different players would make different choices given the same input, even from version to version of the same player. This made it effectively impossible for content providers to control where their clients went. So that led us to content steering. First, we want to give providers control over where their clients got their content in both planned and unplanned circumstances. We want to allow them to change their plan during playback so that they could respond operationally to outages. We want it to be simple and easy to implement. And finally, we didn't want it to be specific to HLS. We want the same steering infrastructure to be reusable with other protocols such as Dash. So let's talk about how it works. Every playlist belongs to what we call a pathway. A pathway is a complete collection of playlists for a particular media asset. So if you have two pathways, you have two different ways for a client to reach the content. The client loads what's called a streaming manifest from a streaming server. The manifest has a list of all the pathways in their preferred order, and the client will stay on the first pathway in the list until things change. Am I ahead? No. Okay. The steering manifest also contains a time to live and a reload URL. The client will wait for the TTL and then reload the manifest via that URL. That gives it a new manifest and maybe with a different TTL and or reload URL. It can also contain an updated pathway priority list and maybe pathway clones, which we'll get to in a second. But here's the steering manifest. It's just a JSON file, and the main thing it's telling the client right now is that it should be on path A, which is the first entry in the pathway priority list. Content steering defines client behavior. This is what gives the server their control. Clients must start on the pathway specified in the steering manifest and stay on it. Only if they cannot load any files on or tiers on that pathway are they allowed to penalize it and switch to a lower priority pathway. Hopefully it doesn't come to that though, because the client is regularly reloading the manifest. And that means that once an operator identifies a disruption of service, it can reorder the client's pathway list, which will make it switch to somewhere else, hopefully before viewing is affected. To do that, streaming servers often make per client or per region choices. Providers want their servers to be stateless, so it allows migration and redundancy. So what they typically do is put their per client info into the reload URL as query parameters. That way, the server gets them back when the client requests its next manifest, and the server has to run its decision logic again. In addition to the server-defined state, a limited amount of information is provided to the server by the client. It also goes into the reload URL's query parameters, and it includes the pathway the client is currently on and the client's estimate of the throughput on that pathway. Now, occasionally, an operator will run into a condition it didn't predict when it provided that initial set of pathways. It has one more tool available, and that is pathway cloning. Even though the client starts with a static set of pathways, a steering server can add a pathway clone to the manifest. This is a copy of an existing pathway with certain well-defined modifications, such as a new host name, replacement host name, or altered query parameters. Once a clone is defined, it can go into the priority list to make the client move somewhere new. Here is our example steering manifest with a pathway clone. This clone defines a new path, path C. It does that by replacing the host name in all the path A URLs. It also puts C at the top of its priority list. So that's the framework. But content steering isn't designed as a standalone protocol. It's intended to work within a host protocol. Today, that means HLS and Dash. To adopt content steering, the host protocol defines bindings from content steering terms to its native elements. So for example, in HLS, the content delivery protocol is HLS itself. The content description is the HLS multivariant playlist. And a pathway ID is the HLS pathway attribute in the multivariant playlist. Dash will then take those same terms and bind them to its own components. Since we first introduced content steering in 2022 with iOS, many other players have added support for it. It is broadly supported by streaming tools vendors and infrastructure providers. It is used by some very large streaming services to steer their global traffic, including Apple TV. And remarkably, it's stayed stable for years. People they're not asking for changes, they're just using it. So that's great. The spec itself is currently an internet draft. It was originally specified as part of HLS, which is now in its second major incarnation, BIS. But in response to industry requests, we pulled it out into a separate specification. One that is not specific to HLS, and in fact, it's not specific to media streaming at all. Any URL-based delivery protocol can adopt it just by defining how its URLs map to pathways. I want to acknowledge that we did receive a great deal of helpful feedback from the HLS interest community in the IETF, and that helped us define something that would work for everyone. So, what's next for content steering? We plan to publish it as an RFC, mainly so that other specs like HLS and Dash can reference it normatively. Today, we publish HLS as an independent submission on the informational track. So it's likely that we'll do something similar for content steering. We're working with ICE on that. That's it. Unfortunately, we don't have a lot of time here today, but if we have any time left now, I'll take questions. Otherwise, please find me afterwards, hit me up. Love to hear what you think about content steering or HLS, and hopefully answer some questions. Thank you.
We do have a few minutes for questions if people want to put themselves in the Meet Echo queue and ask any questions. Right. Our next presenter has a question.
All right, comes loaded.
Thank you, Roger, for your presentation. I was just wondering, what are the rules that the industry using the content steering to kind of select the best CDN in terms of quality experience, in terms of the cost, because that's something that we are working in research heavily with my students. And we design like dynamic rules to switch between CDNs, but I'm just wondering from the industry perspective. Thank you.
Right. So the question is about essentially what the industry is doing in terms of how they decide to switch. It really it depends on the provider. It depends on their particular situation, their constellation of URLs. What we tend to find is that providers tend to fall into two camps. They define a static set of, per client, per region of things they like, and they leave it there. And then they sort of respond operationally to, oh, okay, there's an outage in this CDN in this country, and so I'm going to move people off to something like that. They do have information from the client, like the current bit rate and pathway that they can do some things with. I personally haven't heard of a lot of interesting work being done there yet, but also one of the weird things about building a technology that just works is that you often don't hear about it, right? People go off and they use it and it's working, and you find out about it later, but they don't have problems, and so they don't come to you and say, hey, how do I do this? And so it just sort of, it's a little bit opaque there. So but it's kind
of more static where you assign weights, right, per CDNs, and then you
You can do it. You can do it that way, and that's the easiest way to do it. And so that's what the first thing people tend to do.
Thank you.
Welcome.
Leif?
Leif Edstrom, Apple. So you do have an explicit TTL in the manifest in the JSON. How does that interact with caching intermediaries?
Mhm.
And specifically, why aren't you using the cache control, say max age or something like that, to make sure that the caches
Mhm.
and the client use the same TTLs?
Right. What we have found is that so first of all, the steering server tends to be independent of the proxy caches. And so the question of scaling the streaming server is independent of scaling your content delivery. And what we found is that the payloads, the traffic of steering services is not so great that it really demands a lot of caching. And so I think most of the implementations I'm familiar with don't cache. I think that if we get to the point where it becomes, where people are coming to us and saying, hey, I'm trying to cache my steering manifest and I'm having these problems, we'll certainly look at it. It's a good idea.
Okay, so Ali, really quickly, because we're over time. Jenna, I'm sorry, I had to lock the queue.
Very good question. Hey, Roger. Since our AD is here, I would like to ask the question whether this working group, wouldn't we be really interested in publishing this as an RFC, like as a proposed standard, as opposed to just an informational RFC?
I'll let our AD speak to that.
Yeah.
I mean, given the fact that the MPEG and others are going to just, cite this, I think having a proposed standard as an RFC will make it stronger.
I don't disagree that having a standard RFC would make it stronger, point taken, but not in this group. This group cannot standardize any protocol, clearly. This is in the charter.
And even in terms of publishing it as an informational, if we took it on as a working group item, we would have working group comments. And I'm not sure that the current authors are up for that. I think your point, Roger, is to publish it as it stands so that.
Yeah, I mean, so the function of the informational series is, one of them is to document existing industry practice, which is kind of what this is. To the point of it making it a stronger standard by going on the standards track. That is something we think about now and then. It is something that is, still up for discussion.
Okay, so that sounds like there's some future discussions there offline. Great.
Yep.
Thank you very much, Roger.
Great. Thank you.
And next is Abdullah.
Stop sharing. Stop sharing. Okay.
Thank you.
That they can see.
And the clicker. Is the clicker set up?
Yep. Okay. So like this and this. Okay. So thank you. So luckily I make it in person. I just finished my class with my students. So I was like running from Concordia to here. So anyway, so my name is Abdul Haq. I am professor at Concordia University and I am the founder and leader of ENTGM Lab. So we do a lot of stuff related to video streaming, including like content streaming, designing new rules, as well as media over quick. So as a motivation, I think all of you knows like the video traffic is the majority of the internet traffic, where 65% of internet traffic is the videos, and that majority of it is like, not majority, but I would say part of it is generated by HAS or HTTP adaptive streaming protocols, either Dash or HLS. And this system is historically tuned for like, thank you, TCP and HTTP. So you have HTTP 1.0 or HTTP 1.1 and HTTP 2. So however, we have well-known limitations for TCP, for example, head of line blocking. If you have like one packet loss, that actually kind of disturb your streaming session because the TCP stack need to retransmit that packet. You have slow start latency because of the congestion control, and it will be very hard like to kind of innovate on the top of TCP because it requires a lot of engineering work, right? Because it runs on the kind of the OS level, not the user space, in contrast to QUIC, right? Which is the new
standard, I would say, for it uses HTTP3 at the application layer, and it provides an amazing features that we can leverage for video streaming, for example, security, multiplexing, and priority, but you have to use them properly for your applications. Anyway, so in this presentation, I would love to answer these two questions, whether if we simply migrate from TCP to QUIC, whether that give us a superior quality of experience, and the second thing, whether if we optimize the transport layer, let's say designing a new congestion control for QUIC based only on the information that we get from the transport layer, whether that can improve the quality of experience. Okay, so if you look to the spec, I mean, QUIC provides an amazing features that can help us in improving our quality of experience. For example, it ensures lower handshake thanks to 0 and 1 RTTs feature, and that actually lead to a faster startup from the application layer. You can use multiplexing, where you can parallelize the requests and responses for different, I would say, streaming assets, let's say video, audio, manifests, and advertisements. You can design a custom congestion control, and you can tune them as per the applications, and you can get actually a lot of feedbacks from the user space of QUIC, and then you can use them for your applications. And here I'm talking about HTTP adaptive streaming application. When you look to initial finding that uses a DOS over QUIC, for example, or HAS over QUIC, you can see a mix of results. For startup delay, QUIC wins compared to TCP, thanks of the 0 or 1 RTT, so it's faster handshaking. For rebuffering, depends on the scenario, depending on the network condition, I would say, depending on the deployed congestion control, and also depending on the adaptive queuing management that you are applying at the network layer. For the throughput, it's similar to TCP, and of course, it's less head-of-line blocking. If you have that issue, it will be just within one stream, right? Because QUIC supports multi-stream anyway. So the conclusion that we had from the research, or from the initial results that we got, at least, the QUIC helps, but it's not the silver bullet, right? Why? Because you have a lot of heterogeneous implementations, and you can look to this interop, I think more than 15 to 20 implementations. We tested all of them, to be frank with you. Also, we find the behavior of congestion control in TCP is totally different in QUIC, even it's the same congestion control, right? Because those congestion control are well tuned for TCP, not for QUIC. And for the loss recovery, is not always better than TCP. So yeah, our study is here in this archive. Feel free to download it. So basically what we did here, we kind of fixed the streaming setup. We have a server that runs around, I think, 10 to 15 implementation of QUIC. And we have the client, which is a Dash-based client, is using Go language. And for actually the client, we use QUIC Go implementation, but for the server, we vary those implementations. And we run the experiment by fixing the ABR, fixing the network conditions between the client and the server, and also fixing the congestion control to QUIC, as you can see. So from this graph, as you can see, the VMAF results, those are VMAF results for different implementations. So the red ones are worse, performing QUIC implementations. The blue one, standard performance, it's good. And green one is the best one, right? So here, VMAF, the higher is the better. As you can see, even we fix everything, we get heterogeneous results, right? Which means those implementations differ to how they treat the congestion control, how different implementation languages, I would say, and we list all of the possible reasons in our paper in details. Similarly, we did the same setup, but we just changed the congestion control to BBR, and then we get a list of, I would say, other results. Of course, not all the QUIC implementation supports BBR. Here we are listing just the QUIC implementation that supports BBR, right, where we have top performance, standard performance, and bad performance. So here the main takeaway of these two slides is that QUIC implementations matters for the quality of experience, and that depends on which implementation that you are using, which congestion control you are using, also which the network condition that you are running your application, right? So even actually when we use the same congestion control, but in a different implementation, we get totally different results. Sometimes are good, sometimes are very bad, right? So we saw that move fast from Meta is kind of the winner here, and we cannot treat all this QUIC implementation equally, where TQUIC and IUQUIC yeah, they have a major weakness in two scenarios: video on demand and low latency live streaming. Here, when I say low latency, I'm talking about LL- and LLHLS. So for the use case, we don't find any like an implementation that excel in all the scenarios that we tested. So the paper, I think it's 30 pages. It has a lot of results and scenarios. For VOD, move fast is better. Low latency, we found Queen is the best one. Now let's move to like the second flow. The network is an adversary, not a pipe, and that's what I called like the blind loop, right? Basically, sometimes the ABR selects a bitrate decision that actually distract the congestion control or mismatch the congestion control selection because the client ABR doesn't have the awareness what happened in the transport layer. Similarly, for the server congestion control, it might see stable RTT, right? And it might like grow the congestion control, but you have maybe a queue is building in your router, right? And that's the cycle, that's what we call the blind loop that lead to a negative quality of experience. And here I explained one of the scenarios that at least we investigated. To show this like in experiments, as you can see, we did the same. We fixed everything, but here we also fixed the implementation of Quick, where we use more fast, at least for our test is the best one compared to others. And in the right hand side, you can see congestion control Quebec, and the right one is BBR. Here, actually, the two main takeaway that we can see from here, even actually sophisticated AQM, let's say L4S or CODL, cannot fix the problems that the congestion control creates or the ABR creates, right? That's one of the things that we saw. And the second thing, BBR performed better when we deployed with the AQM, and that's because of the design of the BBR, where it tried to model the network and avoid to fill up the queues at the router very fast. So therefore, it gets around 15-point VMAF improvement compared to Quebec, right? So to answer the first question, yeah, Quick alone doesn't guarantee better quality of experience. You have to optimize, I would say. Then the second question. So here, optimizing the Quick alone, I mean like to design or tune the congestion control just based on the network layer telemetries, right? So here, the assumption that we made in the paper that might help you in the throughput and fairness, but that's not necessarily lead to a better quality of experience. And this result shows what I'm talking here. So here, what you can see in the left-hand side is the telemetries of the throughput from the transport layer, and the right-hand side is the application layer VMAP, right? As you can see here, Quebec, for example, achieve a higher median throughput, but with high variability, I would say. Aero, it's one of the congestion control that we designed recently. It uses machine learning, so feel free to download the paper here. So it achieves like a stable and I would say less variability in throughput and lower, I would say, median throughput compared to Quebec. But when you see the application layer performance, you can see like Aero is best, like 86 in VMAF, but Quebec is 78. So here the main takeaway is that a transport-centric Queen cannot be an application layer, I would say, or can be an application layer loss, right? That's the main takeaway from this slide. So to answer the second question is, like optimizing Quick alone does not guarantee better quality of experience. Now let's move. What's the root cause, right? What's the root cause of this? So the root cause, because the optimization that we are doing like in a silos, which means let's say we optimize just the ABR without the awareness what's happening in our transport layer or the network layer. Similarly, we might just optimize the congestion control based on the telemetries for the transport layer, or we optimize the AQM alone without knowing the goals of our application, and that's what lead to these issues. So what's the solution is what we call the cooperative streaming stack that we proposed, where we create a cross layer, where whatever you can see, those like informations are shared like between this layer, and we optimize, I would say, our like modules inside each of the layer based on those telemetries. And here we define 3 principles, such that, like, let's say we use CMCD to allow application to share different telemetries of the quality of experience. And then we optimize our server-side congestion control using those telemetries, as well as the telemetries that we are getting from both network layer. Here I'm talking, let's say, on the ECN marking, for example, as well as from the application layer. And then we have to leverage the network signals. Here, mainly, I'm talking about like either optimizing the AQM as per the application goals, or you can actually provide those ACN markings to the transport layer as well as to the application layer to optimize, right? So if you see those principles, we apply them and we design like new solutions. We have like 3 papers here listed. The principal one, you can find it in this paper, CAQ. You feel free to scan the QR code to get those papers. We have IRE, which is the new congestion control for quick that use machine learning. And then we have the last paper, which which use like the ECN awareness to optimize the application layer and the network, the transport layer, I would say, modules, mainly congestion control and ABR. So these are the final notes. If you don't remember what I've been discussing and promoting, so just remember this slide. So the first thing that at least the conclusion that we got from the initial results that stop optimizing for the wrong metrics, where the transport level metrics like a row throughput might be a poor proxy for a quality of experience. And the conclusion that we had in the paper that a transport-centric win can be an application layer loss. So you have to like allow your application to share those telemetries, let's say using CMCD standard as CMSD, and then you also can send some telemetries from the server to the client using CMSD, for example. You have to build bridges, no walls, in the sense that you allow those applications to share, those 3 layers to share telemetries, right? And that's what we call the cross-layer solution. And then you might say how we know the correlation between all those telemetries. Here we go. We can use machine learning, which is very good tools that allows us to understand the correlations between these metrics and to give us kind of holistic, I would say, decisions. I think that's all. So thanks. And I would love also to thank my students who did all these studies. Yeah, thank you so much.
And thank you very much. I think we have time for one question. Does anybody have one question? Go for it, Jenna.
Thank you for the presentation. Jana Iyengar, Netflix. Is this mic working? This presentation started thank you, by the way. Started very narrow, but you sort of went on to express a pretty large research agenda, which is hard to disagree with. So I think it's generally like congestion control and ABR should work together with the network. Absolutely. We've all wanted that for, I don't know, 40 years. But I think it's valuable to try and go there. The only thing I'll point out is that when you're looking at different quick implementations, the thing to keep in mind is that, as you pointed out, not every implementation is by default tuned for video delivery. So it's really important to be careful in signaling what you want to say there. Move Fast in particular is tuned for video delivery because Meta does video delivery, and the same for Google's Quiche. And you'll see those differences between the stacks because of what it is that the application they're tuned for. So I would say that just be mindful as you're working on them. The authors are all around here, so you can talk to them about exactly what they're tuned for. And that might actually help you to reduce the set of applications that you're looking at when you're focused on just video QA. The set of implementations that you're focused on.
Yeah, the main reason why actually we did that, because we consider, of course, it's an assumption at the end. We started with that, of course, the majority of like the traffic is video because of this video streaming, and also the multimodal like generative AI nowadays, right? So now they are generating like a lot of, I would say, image and video traffic, right? So that's the assumption that we started with. So I think I agree 100% with you, like those implementations. And to be frank with you, we found some bugs that my students already reports through the GitHubs, that's for sure. But here also, when we see like, let's say the same implementations that we, let's say of congestion control that we like bring from TCP and put it in Quick, some, as you mentioned, because maybe those implementations are well tuned for video streaming traffic, they excel compared to others. Maybe others are deployed for other type of application. I 100% like agree with you, and that's something like in our ongoing work we are considering. But it's not easy to deal with all those implementations. For example, in the experiment here for the client, we just use like a quick go. In fact, we can use another implementation, and we see like their interactions with the server-side implementation. So I would say, as you mentioned, the scope is very, very, very big. But what I wanted to promote that cross-layer sharing, and I hope, like, I know that there are a lot of standards that are trying to share those things, but I believe we need to have also some intelligent layer in our TCP IP stack or quick IP stack, I would say, to help us to do that decision. And that's what we are trying to promote here, that cross-layer sharing between these layers. And we go beyond that, not only the network layer. I have another student that is investigating the data link layer from the 5G networks as well as the physical layer. So we are trying to have that cooperation between all these layers for a better quality experience. Yeah, thank you.
Thank you again for your talk.
Yep. Thank you. And thank you very much I'm glad we're able to make it in person. Do you find, as Jana mentioned, there are many implementers here. Do you find them in the hallways, and hopefully it will be helpful for your onward work?
It will be great because for the research, that's what we want to
Yeah.
bridge the gap between the academia and
Yeah.
the industry. And then one of the biggest issues, like the data, we don't have really work there.
Great. Yeah.
Okay.
Great.
Yes.
Thank you. Glenn?
Hello, I'm Glenn Dean from Comcast NBC Universal. I'm going to warn you ahead of time because I know I'm between you and lunch. I'm going to try to deliver this at a significant fraction of an Ecker. So I come from the SVTA to the IETF and do a presentation to sync the two organizations each time. This is the IETF 124 version. This one covers the SVTA gets edgy. I'll explain what that means in a minute. We were here last week, so if you were just down the hall, you would have been able to come to the SVTA meeting. So in the world of video, we are undergoing a revolutionary change. A lot of people don't realize it, but if you look back into the 90s through 2007, those were the early days, and we were asking the question, how do you do it? We had a lot of different implementations and a lot of different approaches. We had push me, pull me, pub sub. Eventually, HTTP won out as a transport mechanism for standard video because it got through firewalls really effectively. So from 2007 to about this year, we have been doing video on demand at scale development and architecture across the industry and across the IETF. And as a result, we got really good at it. But there's a use case we left out, and Lenny touched on that a little bit, and that is live. Live does not work really well necessarily against the traditional video on demand infrastructure. So in this new world, we're evolving again, right? Things were evolving, the ways we deliver, the world of the CDN. We're also seeing a revolutionary change around the new development of new protocols. We got things like MOC on the horizon. We've got Quick, we've got proprietary protocols, once again being new developed. This is the new golden age of streaming protocols. It's kind of a cool time to be an engineer. Again, I'm doing this at a fraction of an Ecker. So if you looked at the SVTA back in the day, 2015 when it was founded, very few working groups, very much focused on video on demand and open caching was the use case. That tied back into CDNI here at the IETF. Now in 2025, we've grown, right? There's a lot of other working activities going on there. And I'm going to talk to you about one of them today, which is Edge. So there's a new specification coming out from the SVTA. These are publicly released eventually. This one will probably be released late this year, early next year. It's on how do you do hosted caches at the edge. This is not a specification covering the cache itself. The idea is that we're going to provide a standard reference environment for hosting caches that can run themselves on different protocols. So if you want a mock relay, it could be a mock relay. If you want to do traditional HTTP2, you can do traditional HTTP2. Whatever you want to bring to the party, the idea here is that this provides a standard reference environment for hosting it in. So what topics are we working on? Forgive me for the fine print. Pull down the slides at home for your edification. I pulled out 3 chapters from this draft foundation spec that are currently in draft and to give you a sense of the target areas that it's covering. The key thing to keep in mind here is that there's 3 roles that it's focusing on defining. One is a tenant. This is the hosted cache thing. The hosted service provider, it's a new role. It's the job of the hosted service provider to provide the compute, memory, and infrastructure to host a cache and treats a cache very much like a black box. And finally, the network operator provides networking and transport. And there's a new integration and awareness we've envisioned between the hosting service provider and the network, much more awareness than there has been in the past. So chapter 7 then gets into all the details of all the difficult things. content steering's in there. So Roger, pay attention. We're talking about content steering, networking, addressing, all that kind of stuff. So if you're a cache operator, you might be interested. If you're a network operator, you might be interested. If you're a streaming platform developer, you might be interested in this work. And chapter 8 gets into actually how you run this, right? Because SVTA in many ways is like Nanog for networks. It's Nanog for streaming. And so we focus on how do you take the technology and roll it up into something you can actually deploy operationally. And so these are all operational workflows and concerns that we're working on. Again, specifications planned for a publication later this year. That could mean January from when it actually gets through the publication process, but it's coming. If you are a member already of the SVTA and you want to help with the specification, we would love to have you in the room. If you're not a member already, come see me. So I'm Glenn Dean. I'm from Comcast NBC Universal. I'm the MOPS technical thing, and I'm the president of the SVTA. So I love this stuff. So I'll try to help you connect the dots when I can. Did I make it on time?
Yes, thank you. And while our AD is coming up for a couple of announcements, are there any questions for Glenn? You can take one. Jana.
And how did I do on the Ecker meter? Did I approach 1 Ecker? No? Okay.
No, you were 20%, man. But I mean, it's curious. It's not curious. It's amusing that you're thanking yourself on the last slide. But it's funny. That's all. It says thank you, Glendine.
Oh, I see. Thank you. I am Glenn.
Sorry, that wasn't actually my question. That was my stupid little Jana Enga Netflix. Then how would one participate in these meetings if one wanted to? The document looks very interesting. First, how would I get it? And second, how do we engage in the discussion?
If you're an SVTA member, and you are in fact an SVTA member, we meet. There's you log into the Arrow system, and it has the calendar of all the meetings. I think we currently meet regularly Thursdays on 9 a.m. But we've been having multiple calls per week trying to get this thing done.
9 a.m. What time zone?
Oh, Pacific. I apologize, Pacific.
Thank you, Glenn.
So Eric Ving, responsibility there. I have a sad news somehow because Kyle has decided to retire from the working group chair position. So Kyle, thank you for your service. For many years, we started from nowhere. And this group now is very active. I mean, it was one of the most enjoyable sessions of MOPS, this one. And the other one were good as well. It also means that I am looking for a new working group chair. So if you are interested, or if you know somebody that could be interested, please come to see me, either this week or by email or whatever. So thank you again.
Great. Thank you, Eric. I promise I don't bite. So if Eric doesn't fire me and as your potential future co-chair, happy to have a discussion about it. Thank you, everyone, for coming. Thank you to the people who put together material and presented it. And thank you also to our note taker, Chris Lemons. All right, go have lunch.